Question 1. The diagram below shows a right angle triangle ABC such that AB is equal to x plus 1 cm, BC is equal to x plus 2 cm, and AC is equal to x plus 6 cm. A. Show that x squared minus 6x minus 31 equal to 0. Since we have the length of all the three sides and we are told that it is a right angle triangle, we can apply Pythagoras theorem in this question. AB square plus BC square is equal to AC square. Substitute the length. X plus 1 square plus x plus 2 square is equal to x plus 6 square. Then we expand the bracket. We get x square plus 2x plus 1 plus x square plus 4x plus 4 is equal to x square plus 12x plus 36. Then we simplify the equation and let it be 0. We have 2x squared from the left side minus the x squared plus 6x minus 12x plus 5 minus 36 equal to 0. Therefore, we get x squared minus 6x minus 31 equal to 0. B. Find the value of x. We continue from the equation we obtained in part A. X squared minus 6x minus 31 is equal to 0. To solve quadratic equation, we have three methods: factorization, completing the square, or by using formula. If we choose to do factorization, we have to look at the constant. 31. So 31, we only have one combination, which is 1 and 31. 1 and 31, if we add them, we can get 32. If we minus them, we can get 30. But here, we need to get a negative 6. So this quadratic equation cannot be solved using factorization. So here, let's use formula to solve for the x value. Our A is equal to 1, B is equal to negative 6, and C is equal to negative 31. X is equal to negative B plus minus square root of B squared minus 4AC over 2A. Simplify the equation. We have 6 plus minus square root 36 plus 124 over 2. And we will get 6 plus minus square root 160 over 2. Square root of 160, we can separate it into 16 times 10, which is square root 16 times square root 10, and we will get 4 square root 10. So here we will get 6 plus minus 4 square root 10 over 2. Simplify the equation, we will get x is equal to 3 plus minus 2 square root 10. Therefore, we will get x is equal to 3 plus 2 square root 10 and also 3 minus 2 square root 10. 3 minus 2 square root 10 is a negative value. In this question, our x is the length of the side. Therefore, 3 minus 2 square root 10 is invalid. We have only one solution for this quadratic equation, which is 3 plus 2 square root 10. Question 2. The diagram below shows a trapezium PQRS where PQ is equal to x minus 1 cm, PS is equal to x plus 3 cm, and QR is equal to 3x plus 2 cm. Given the area of the trapezium is 17 cm square, find the value of x. Recall, if we have a trapezium that looks like this, and this is A, this is B, and this is C. The area of the trapezium is half multiplied with A plus B multiplied with C. We are going to apply this formula in this question. Area is equal to half PS plus QR times PQ. Substitute the value into the length. We have half multiplied with x plus 3 plus 3x plus 2 multiply with x minus 1. Simplify the equation. Half 4x plus 5x minus 1. And we are given the area is 17 cm square. 17 is equal to half multiply with 4x plus 5 multiply with x minus 1. We multiply both sides with 2 and we also expand the bracket on the right side. We will obtain 34 is equal to 4x squared minus 4x plus 5x minus 5. This is a quadratic equation. Let's rearrange it into the general form. We have 4x squared plus x minus 5 minus 34 equal to 0. Simplify it. We have 4x squared plus x minus 39 equal to 0. Let's factorize the equation. For 4, we have two combinations, 1 times 4 or 2 times 2. For 39, we have 1 times 39, 3 times 13. We have a few combinations here, so let's try. For x squared, we can make it into 4x and x. And 39, let's try 3 and 13. For here, we will get 3x. And for here, we will get 52x. Very obvious, this is not the combination we want because we will get 55x or 49x. Let's exchange the position of 3 and 13. We have 13 here and 3 here. So now, the middle, we have 13x. And the outside, we will have 12x. If we add them, we'll get 25x. If we minus, we get x. X is the value that we are looking for. In order to get a positive x, we plus 13x minus 12x. The positive follow the 13x. The negative follow the 12x. And lastly, need to check positive and negative. We will obtain a negative. Therefore, 4x plus 13 is equal to 0. X is equal to negative 13 over 4. And the other one is x minus 3 equal to 0. X is equal to 3. And same as question 1, the x value here is the length. So we do not accept negative value. So x equal to 3 is our only solution. Question 3. The roots of the quadratic equation 3x squared plus nx plus 2 equal to 0 are in the ratio 2 to 3. The information we have is the equation 3x squared plus nx plus 2 is equal to 0. And we let the roots be alpha and beta. So the ratio of alpha to beta is equal to 2 to 3. We rewrite it into a fraction form. Alpha over beta is equal to 2 over 3. Our alpha is equal to 2 over 3 beta. A. Find the value of n if n is greater than 0. The n is actually our b. From the information we have, we can find the sum of roots and the product of root. The sum of roots is equal to alpha plus beta, which is negative b over a, which is negative n over 3. The product of root is equal to alpha beta, which is 2 over 3. The equation for sum of root contains 3 unknowns, and the equation for products of root contains only 2 unknowns. So we will solve for the product of root first. We let this equation be equation 1. Substitute equation 1 into the product of root. 2 over 3 beta multiply with beta is equal to 2 over 3. 2 over 3 beta square is equal to 2 over 3. Since we have 2 over 3 at both sides, we can just cancel them. Therefore, we get beta square equal to 1. Beta is equal to plus minus square root of 1. So beta is 1 and negative 1. We substitute equation 1 and beta equal to 1 into sum of root. 2 over 3 beta plus beta is equal to negative n over 3. 5 over 3 beta, our beta is a 1, is equal to negative n over 3. Therefore, our n is 5 over 3 multiplied with negative 3. We get negative 5. We do the same for beta equal to negative 1. Substitute equation 1 and beta equal to negative 1 into the sum of root. We get 5 over 3 multiplied with negative 1 equal to negative n over 3. N equal to negative 5 over 3 multiplied with negative 3 is equal to 5. And we are told that n is greater than 0. So this answer is invalid. And our n is equal to 5. B. Hence, find the roots of the equation. In part A, we already found our beta, which is negative 1. So one of the root is negative 1. And our alpha is equal to 2 over 3 beta. Substitute beta equal to negative 1. So the second root will be negative 2 over 3. Question 4. One of the roots of the equation 2x squared plus bx plus 2 equal to 0 is 4 times the other root. Find the possible values of p. We have the equation 2x squared plus bx plus 2 equal to 0, and the roots are alpha and 4 alpha. We are asked to find the possible values of p. Let's find the sum of root, which is alpha plus 4 alpha equal to negative b over a. 5 alpha is equal to negative p over 2. The product of root is alpha multiplied with 4 alpha equal to c over a. Therefore, 4 alpha squared is equal to 1. We can solve for the alpha first. Divide both sides with 4. Alpha squared is equal to 1 over 4. Square root both sides. Alpha will be plus minus square root of 1 over 4. Therefore, alpha is equal to 1 over 2 and negative 1 over 2. Then we continue over here. We substitute alpha equal to 1 over 2 into the sum of root. We get 5 multiplied with half is equal to negative p over 2. P is equal to 5 over 2 multiplied with negative 2. And p is equal to negative 5. We substitute alpha equal to negative half into the sum of root. 5 multiplied with negative half is equal to negative p over 2. P is equal to negative 5 over 2 times negative 2 and is equal to 5. For this question, we are not told any other condition. So P is equal to negative 5 and 5. Question 5. A quadratic equation 2x squared is equal to 6x plus 3 has two roots p and q. Find the quadratic equations with roots p square q and pq square. 2x squared is equal to 6x plus 3. So let's rearrange it into the general form. We have 2x squared minus 6x minus 3 is equal to 0. And our A is equal to 2, B is equal to negative 6, and C is equal to negative 3. We are also given that the roots are P and Q. Let's find our sum of root and product of root. The sum of root is equal to P plus Q, which is equal to negative 6 over 2, which is 3. The product of root is equal to P multiplied with Q, which is negative 3 over 2. We are asked to find the new quadratic equation with the new roots. Our new roots are P squared Q and PQ squared. We're going to find the new sum of root and the new product of root by using the information we have. The new sum of root is equal to P squared Q plus PQ squared. Factorize them, we can take a P and a Q out. PQ bracket P plus Q is our sum of root. Substitute the value. PQ is negative 3 over 2. P plus Q is a 3. Our sum of root is negative 9 over 2. The new product of root is P squared Q multiplied with PQ squared. Simplify it, we get P cubed Q cubed. We can take the cube outside. So we have PQ cubed. Substitute the value of PQ, negative 3 over 2 cubed. We get negative 27 over 8. Therefore, the new equation is x squared minus the sum of root x plus the product of root equal to 0. Expand the bracket and multiply the equation by 8. We get 8x squared plus 36x minus 27 equal to 0.